The event page shows information about the earthquake, as well as the peak accelerations recorded for each sensor. The status of this event is inspection recommended, which means there has been significant shaking to warrant an engineer inspection. Below are the types of data available for this event. Let's start by taking a look at the acceleration data. Our sensors have triaxial accelerometers that record data at 250 samples per second. A bandpass filter is used to remove noise and focus on wanted frequencies. This can be toggled on or off here. You can show or hide specific sensors on the graph by clicking the legend on the right. You can also download the data in CSV format or generate an event report, which includes all the information and graphs for this event. Next, let's take a look at velocity and displacement graphs. Velocity and displacement graphs are provided by the integration of acceleration data. These graphs can be indicative of damage to the structure of the building. For displacement, data can be shown as either the absolute displacement, the displacement relative to ground, or the inter-storey drift. Inter-storey drift displays the difference in displacement between each subsequent floor. Rotation graphs, which show the angular acceleration, velocity, and displacement around the vertical axis, are available when there are two sensors installed on the same floor. The response spectra is a tool used to describe the peak acceleration response of a structure over a set of specified periods for each event. The NZS 1170.5 standard defines a hazard spectra curve for which the ground response spectra can be compared with. A ground response spectra, which exceeds the NZS 1170.5 hazard curve, can indicate that the design forces of the structure have been exceeded. Fourier amplitude graphs provide information about the frequency content of the recorded data for each floor. The peaks and relationships between each floor in the Fourier amplitude graphs can indicate different modes and natural frequencies for the building. Lastly is the building frequency graphs. These graphs show the fundamental frequencies of the building as determined by each of the events recorded. Fundamental frequencies are calculated for each event by the maximum ratio between the Fourier amplitude of the top and ground floors of the building. A drop in the average fundamental frequency following a large earthquake can indicate structural degradation of the building.